Alright, so in this video we're going to talk about the product of two functions. If I have f of x times g of x, what is its derivative? And it's very tempting to want to say, well, that's going to be f prime times g prime. Because so far derivatives have worked out pretty nicely and, it behaves well with respect to sums. So maybe it could work well with respect to products. But we're going to see quickly that that's not true. So for example, is the derivative of x times x the same thing as the derivative of x times the derivative of x? Well, x times x is x squared, so its derivative is 2x. The derivative of x is 1. I mean, it's a linear function whose slope is always 1. And so is that, so we get 1 times 1 here, and these things aren't the same. Right? So it's not true that the product of two functions gives us, or that the derivative of a product is the product of the derivatives. We're going to have to do a little bit more work than that. So what this thing turns out to be is f prime of x g of x plus f of x g prime of x. And if that doesn't seem so clear, there's a good reason for that. So this thing is equal to, by definition, the limit as h approaches 0 of f of x plus h times g of x plus h minus f of x times g of x all over h. I'm going to do a trick here that's underrated in math. And what I'm going to do here is I'm going to add a 0 to this. But not any old 0. What I'm going to add to it is I'm going to add minus f of x g of x plus h plus f of x g of x plus h minus f of x g of x over h. Now, do we agree that this thing is 0? That plus that is in fact 0? And so, just like before, I get to play algebra games with this. There's a common g of x plus h here. I could split this thing apart. And so I could work a lot of algebra to show that what I get is f of x plus h minus f of x over h times g of x plus h. That takes care of this, right? Plus the limit as h goes to 0 of f of x times g of x plus h minus g of x over h, and that takes care of this. And so this thing is by definition f prime of x, and this thing is by definition g prime of x, and boom, I have my sum. And so if I want to put this into practice, I could say, all right, let me erase some stuff here. Let's say I want to find the derivative of x times x, which, by the way, we already know is 2x. According to my formula here, I should get the derivative of the first function, which is 1, times the derivative of the second. So remember that this is like some f and this is like some g, right? So I get f prime g plus f g prime. So I get x plus x, which is 2x, right? Which is exactly what we said that it was going to be. So that's nice, but it seems sort of contrived. We wouldn't actually use a rule like this to evaluate x times x. So what about the derivative of x squared times e to the x? Well, again, this is like some f, and this is like some g, right? So I'm going to get f prime, which is 2x, times g e to the x plus f x squared times g prime, which is also e to the x. Right, so we can make note f prime g f g prime. And we didn't have any rules, right, to evaluate stuff like this. I knew how to do this and that, but not that. And so the product here gives me the product rule here gives me the tool that allows me to do that.